This is AP Calculus, lesson 6-1. We're talking about slope fields. Where are we in the unit? We only have 3 lessons this unit. We're on 6-1. This test for unit 6 is actually going to be our final, so we'll be taking that during whenever our final is going to be. All right, let's jump right into the lesson. So here's a setup. Go ahead and copy that down. Now that you've unpaused me, what is a slope at a point before we move into a slope field? So I'll have some dy dx. Remember, dy dx, that can mean a few things, and let's annotate this. This can be, let's say also that's y prime for this thing. What else is this? This could be a rate. So this is a rate. Maybe you want to think of this thing as f prime. It has many names, and we need to be comfortable with all of them. Okay, so notice that when I'm giving you the function of this rate, this x, y minus 1, this includes both x and y. And I want to write that down because it's kind of important. So this includes, okay, what's going on here? It includes both x and y. That means when I'm plugging in a point, I need to plug into both x and y. So let's go ahead and do that. So here's my same function that I'm talking about here. There's one function on the left, one function on the right. This is saying I am evaluating the evaluation bar. I'm evaluating x equals 1, y equals 1. Remember, it always goes x, comma, y. Therefore, I'm plugging in 1 and 1. When I plug in 1 for x, it's going to be 1 times all of this thing. When I plug in 1 for y, 1 minus 1 is 0. 0 times 1, this whole thing is going to be, well, I guess I should write it. It's going to be 1 times 1 minus 1, and that's going to be 0. All right, that means what? That means that this rate that I was talking about, this means that the rate is 0. So rate is 0. So what's another way of saying that the rate is 0? It means that there's no change. You're not moving. You have no velocity. So there's no change. No change. Always need to be thinking of these in terms of the rates. Eventually we're going to be thinking of them graphically. All right, let's try plugging in a different point. Let's try plugging in 2, 3. So at this point, at 2, 3, at this point, what is the slope? What is the rate? So if I plug in 2, 3, remember 2 goes in for x, so it's going to be 2 times 3 minus 1. That's going to be 2. 2 times 2 is 4. That means I have a rate of 4. Notice that this is f prime. F prime is positive. So therefore, f, the function is increasing or decreasing? It's positive, f is increasing. Okay, let's try it again with a different equation. Notice here I have my rate, my f prime, my y prime, whatever you want to call this thing. It is only in terms of only x. So in terms of only x. It can sometimes be in terms of only y, or sometimes both, like this, some random equation. Okay, so that means that it always depends on x, and it does not depend on y. So if you want to add that as kind of a key thing, this means it only depends. And this might seem pretty straightforward, like, well, obviously it only depends on x, there's only an x. But when you think of this graphically, when you move in terms of the y, when you move up and down, this won't change. It'll be the same value moving up and down, but it'll change going left and right. So it only depends on x. All right, so let's try plugging in. So when I plug in 1, 1, well, where's the y? I mean, I can plug in the x, right? That's going to be, this is 2 times 1. Where does the y go? There is no y. So, I mean, you can think of this thing as like plus 0y, but you shouldn't need to even think about that. If there's not y, don't plug anything in, so you're done. 2 times 1, and that's equal to 2. So this is a rate of 2. Therefore, again, this is a positive slope, so it's a function increasing. F is increasing. Okay, let's try plugging in -1, 0. So valuation bar -1, 0, what is that going to be? Go ahead and do it yourself. It's going to be 2 times -1, no y to plug in, and that's just going to be -2. That's going to be a function decreasing. All right, so that's it for up here. So I gave myself some blank space right here. Hopefully you did in your notes too. What are all of these things? It has a title attached to it, and it is kind of the title of our unit. It's not the exact title of the unit, but it is the type of question that can be asked on an AP test for your response, and it is differential equations. Differential equations. Anytime you see one of these things and you're trying to find it, what is this thing? What is this thing? What is this thing? What is this thing? You are asked to find the differential equation. It means you have something, d something over d something. That's a differential equation. Our next slide is going to be really quick. It's just this one thing. And we're almost done. We have this last slide to get to. But for this one, go ahead and copy down the setup. All right, so you have now unpaused me. In the top here, I'm just saying this is the rate. The rate is 0. The rate is 1. The rate is -1, and so forth. What does that look like graphically as a line? So a rate of 0, how would you draw a line for 0? What would it look like? So go ahead and try to take a guess yourself. You can always erase it. All right, so, and maybe I should bring my line tool so that I am also correct. So the slope of 0 is going to look like that, just a flat line, no heart rate. Okay, so what does a slope of 1 look like? Go ahead and make that slope. All right, so hopefully you did something like this. And I have to be very specific here, and this is where basically everything is very exact. When you do a slope of 1, it cannot be this. Here, let me do something bad. Let's do it in green. This is not a slope of 1. Nor is this a slope of 1. It needs to be a 45-degree angle. Make sure you know that this is a slope of 1. And I don't want to put those there because it'll confuse us. But I already started the notes out here by saying you have to be able to draw, and well, yes, that's true, you have to be able to draw, but you have to be able to draw a slope of 1. And if you don't know how to do that, think about a square. And think about going from the diagonals of the square. That is a slope of 1. That's how you should visualize that slope. All right, so moving forward, what is a slope of -1? Take a guess. Okay, slope of -1 looks like that, connecting the little corners of the square to make sure it's nice. Okay, what about a slope of 2? Okay, so these two, they don't have to be exact, but they should be pretty darn close. So again, you can think about this as stacking 2 boxes and connecting their corners. But generally speaking, a slope of 2, and I'll make this note here too for us, this dy dx equal 2, this thing has a, I'll say steeper, I think we're okay with that word, oops, let's spell that correct, Mr. Sindel, steeper, should say has a steeper slope than dy dx equals to 1, dy dx, then a rate equal to 1. And that's really all the AP graders are going to look for on your tests, is that you have a slope that's greater than this slope, a slope that's steeper. And finally, our rate of -2, that should look like this. All right, moving to the next slide. This is our last slide, and it's finally solving the differential equations. So we have our dy dx, our y prime is equal to 2x. It only depends on one variable this time. So what is this thing? Look, I found dy dx. What is the name of that thing? Do you remember? Maybe you can come back here to this slide. It's a differential equation. It's one of these things. So let's label this. This is a differential equation. Differential equation. Okay, and then how do I solve for that differential equation? Well, to solve an equation, that means that I am just solving for the variable. So let's write that down here. So that's getting variable by itself. Get variable by itself. So when I'm solving a differential equation, that actually means I'm taking the antiderivative. So this is taking the antiderivative. And I apologize, I need to go ahead and delete all of that because I actually forgot to add that to the original video, so that won't show up until the notes that are printed out in the PDF. So when I solve, really what I'm asking for, what is the antiderivative? Antiderivative. So when I take the antiderivative of 2x, I get x squared. I divide it down by the 2, that's where the 2 disappeared to. And don't forget your plus c. So that is the solution to this differential equation. And what can that look like? Before I actually get what it looks like, I should note here, this has a special name. This is called the general solution. So let me write that out. So this is the general solution. And if we were being exact, we would say the general solution of the differential equation. But what does it look like? So we'll go down here. Let's change to green. So what does it look like? Looks like these. Can you picture what this equation would look like? Because you can't really have a C when you see a real equation in the wild, in the jungle. So it could look like this. It could look like y equals x squared plus 1. Remember, c is just a constant. It could look like y equals, I don't know, make your own, x squared plus 2, x squared plus 0, which is just x squared. It could equal, I don't know, something random, y equals x squared minus 2. C could be a negative. These are what this general solution represents. It represents an infinite number of these equations, which is kind of nice about it. All right, so this will be connected to our graph really soon, but what I want to do now is actually do what the topic was, slope fields, to make a slope field of this differential equation. All right, how do you do that, Mr. Sindel? Very similar to the slope at a point. I'm just going to go through point by point by point using this. Here we go. So I should switch to my line tool here. All right, so this says that I take whatever coordinate I get, the x coordinate is going to be multiplied by 2. So let's look at 0. 0, 0, what is that line going to look like? I'm going to switch to red here for my color. When I plug in 0, I get a slope of 0, and we know what a slope of 0 looks like. A rate of 0 is a flat line. So a flat line at 0, 0 is going to look like, okay, I'm trying to be precise here. I'm trying to make it go through 0, 0. Okay, that's as good as I can get. It's this flat line. What about up here at 0, comma, a half? So what is the x coordinate? The x coordinate is 0. So again, it's still 0. So I still have a slope of 0. Oh, why did it change there? Still a slope of 0. Still a slope of 0 here too. It can be a slope of 0 on all of these because it only depends on x. This line should have gone through that point, but whatever. It only depends on x. All I'm changing up here is a y. So as soon as I make my next jump over for 1/2, wherever that slope is, that's going to be the same going up and down because it doesn't depend on y. It's kind of a cool little shortcut. So let's think about that. Let's go to 1/2. So this is 1/2, comma 0. Again, we don't really care about the y coordinate. The x coordinate is a half. So the slope here is, you called it, it's 1. And we know how to do a slope of 1. It looks like that. And we know that if I made a point here, so right here, and a point here, and here, we would know what each of those slopes is through those points because, again, it only depends on x. It would be a slope of 1. Slope of 1. Okay, what about over here at 1? And I should make my points again. I probably should have done that for the setup. Okay, so at 1, I plug in x equals 1, y equals 0 into this, and I get a slope of 2. So now, again, it just needs to be steeper. It doesn't need to be super precise, but a slope of 2. And all of these also have that steep slope. Slope of 2. I'm trying to make them all the same and still go fast. They all have a slope of 2. Perfect. And there's just a bunch of little dashes. That's what a slope field is. All right, now let's go ahead and make the dots over here on the left side as well. We need dot paper, right? Okay. So when I go to -1/2, this slope is going to be -1. So all of these have a slope of -1. Oh gosh, I'm trying. Diagonal through the square. And then all of these are going to have a slope of, when I plug in -1, I get -2, so even steeper. They should technically all be the same slope, but I'm just going fast here to get through them. We have drawn our very first slope field. That's all it looks like. So technically, this slope field actually is incomplete. We only did it at certain points. That's exactly what you're expected to do on the AP exam, but I want everyone to know what a slope field actually looks like. Like if I had an infinite number of points, what would be happening? So if I were to pretend to be, I don't know, an ant or something that starts right here, and I'm going to go off in the right direction. So once I get here, I'm going to have a slightly more positive slope, where I come out like this, I come up and out. So maybe I should have made that a dash line. I wonder if I can do that still. So I'm going to make this a dash line. I'll do a solid line over here so you can see what they look like. But if I come out here, I should still have a slope of 1 by that point. It's really hard to get this correct. I should still have a slope of 1 by the time I hit there. Look, about a slope of 1, and it keeps going up. And by the time I hit this coordinate, I do have a slope of 2. What about over here? What happens over here? Okay, I can try. Come on, Mr. Sandell, make your parabola better. It comes out like this. All right, I tried. What happens if I started at a different point? What if I started, I don't know, down here? Then my parabola would look like this. Okay, dash line. It would look like this. Or like this. It'll come out this way. Or if I started right here, just choose a random point to start out on the y-axis. You could even start over here and come down to the y-axis. It doesn't really matter where you start. A slope field should work everywhere. And you can see the relationship between this graph that I'm making here, all these blue dashed lines, they represent all of these different equations. This red slope field is the general solution. This blue dashed line are all of these different solutions that the general solution represents. So let's just see another visual representation of a slope field, one that you're not going to be really using, just to see that up the representation. And it would be something like this. You have, we'll do just 3 points to be done with this, but let's say you had your starting point at 0. So this would be your slope field. It would just be a parabola that goes up this way, parabola that goes up this way. Say you started here, that was your, I don't know, we'll say that was your y equals x squared plus 1. We just added 1, and then your slope would come out like this, your parabola would come out like this. And what if you had your y-intercept down here? This would be y equals x squared minus 1. It would still come up like this, still come up like this. So those are your different representations. Usually this is the one that you're going to see on the AP exam. All right, perfect. That is all I have for the notes. So go ahead and write your summaries now. Thanks.